Hi, everyone, and welcome to our Analytics as Code webinar, Don't Let Your Pipeline Die at BI. This is a topic that has a ton of buzz lately, and so we're excited to cover this topic in detail. I'm Greta Brower, Director of Product Strategy and Marketing at GoodData, and I'm going to be your host today. On a housekeeping note, everyone's muted, but please use the chat to ask questions and we will reply to them there. We will also have this meeting recording available to you in a follow-up email in a day or two, so look for that. We have a packed agenda today, and we're going to hear from a number of speakers shown here. They're each going to do their own intro, so let me just get to the agenda of what you're going to hear one by one. Okay, so first we have a discussion between VP of Product Ryan Dolley and renowned analytics industry analyst Donald Farmer. Then we're going to hear from GoodData founder and CEO Roman Stanek about how we are doing analytics as code here at GoodData. And then lastly, we'll wrap it up with some examples of real GoodData customers, how they're using analytics as code, how it's improving their analytics delivery. And specifically, we're going to hear from Vojta Kopal, the Director of Engineering at our customer Mews. Mews is a B2B hospitality software provider who recently hit tech unicorn status. So with that said, we are going to pan over to Ryan and Donald for intros and then a deep dive about analytics as code.
Hey, everybody, and welcome to today's Analytics as Code deep dive. I am VP of Product Strategy here at GoodData, Ryan Dolley, and I am thrilled to be joined today by my friend, Donald Farmer. Donald, why don't you introduce yourself?
Well, thank you very much, Ryan. Yes, delighted to be recording with you again. So I'm Donald. I've been in the business intelligence data analytics space for a very long time. Worked in all sorts of fields here. I'm an independent advisor to software companies and investors and enterprises all around the world on data and analytics strategy.
Cool. Well, it's great to have you here today, Donald, to talk about analytics as code. I think the first question is a simple one, and that is just, what is analytics as code? Where does this idea come from? There are other as code concepts that you hear about. Infrastructure as code, for example, is a popular one. What is analytics as code?
Well, it's a simple question, and I'll try and give it a simple answer. I think the most important thing about analytics as code is that if you think of the way in which we build analytics normally, if you like, traditionally, we have measures, we have dimensions, we have all sorts of hierarchies and things that we create as ways of navigating our analysis. And what are these? When you save them, when you create them in your user experience, what are you creating? And analytics as code is a way of saying, well, what you're actually creating is the underlying code that generates these objects. And that's a little bit different because most of the time when we talk to people about their business intelligence, in a sense, they know that they're creating a dashboard, but they don't know what the components of that dashboard, for example, are. And with analytics of code, you're actually very aware that you're creating components that can then be reused, reconfigured in different ways. So in some ways, it's a way of exposing the structure of analytics to the user in such a way that it can be reused, it can be inherited, it can be modified, it can be versioned and changed over time. All the things that developers have been doing for many years with code. So analytics as code is a way of saving the artifacts and the objects of business intelligence in this highly reusable way. And I think that sometimes the as code word is a little scary to people, and it shouldn't be, because that's really what it's just really what I'm describing. It's a way of objectifying these artifacts of business intelligence in such a way that they can be reused. It's not about everybody learning, Python or learning to write scripts. It's more about the infrastructure behind that enables reuse and collaboration, which is a really important part of business intelligence.
Yeah, and I think often neglected over the years. I as someone who's spent many years as a BI practitioner, I can't tell you how many times I was forced to rework stuff I had already done because there was no way to save off the underlying artifacts and recombine them into something new. So that begs the question, okay, so that's what it is. Why is it necessary? Why now do you think is the time for analytics as code to become a thing?
Right. Well, it's necessary in order to address those problems that you just mentioned. I mean, I've worked in this business intelligence for a long time. I was like everybody else. I was very excited by the self-service business intelligence kind of developments in the early 2000s, and I was fair to say I think I was a large part of developing those products and those strategies, and they didn't work. Well, they worked to a certain extent. I don't want
Right.
to downplay that. They did. But our aim was, we often talked about like the democratizing of business intelligence,
Yeah.
and that really didn't work, because what actually happened was, yes, we managed to enable business users, but primarily power users, to build their own business intelligence. But the lack of collaboration and the lack of reuse was a real problem.
Mm.
And collaboration is absolutely critical in business intelligence, because you're trying to understand the the dynamics of a business, and you're trying to then track and measure those things. And as we've moved from business intelligence much more towards analytics, which is predictive and prescriptive analytics, and now, of course, we're now moving even further towards artificial intelligence and increased automation, the need for collaboration just becomes greater and greater. But we don't have the infrastructure. That those tools are primarily not collaborative. You can sometimes collaborate in terms of commenting, but you can't collaborate in
Yeah.
the creation. But the world has really moved on to a much more complex place. We need collaborative creativity. And analytics as code is a way of enabling that. So its time really has come. It's actually critical that we have a collaborative development environment now for analytics.
I'm curious, why do you think analytics and business intelligence have lagged behind? Like if you look at many other disciplines in technology, they're just much earlier to both this as code philosophy, but the overall embrace of collaboration and many authors of a single object and that sort of thing. Like what has held us up in the data industry?
I think it has been the mindset of the power user, the specialist person who has the keys to the castle when
Yeah.
it comes to analytics and data. We're at a phase where there is a limited amount of data literacy in organizations, and therefore it's not much like the Middle Ages. There's a small number of elite, highly literate users who are creating, the business intelligence artifacts, and that is dramatically changing, because now everybody has access to data, and everybody has the tools which enable them to make at least some sense of data. And of course, we're all much more data literate. And so, data analytics have been lagging behind because people didn't have that pressing need to be able to create their own environments, to create their own objects, and now they do. And if you look at something like infrastructure as code, which is, I think, a very appropriate comparison, infrastructure as code really became critical when we moved to the cloud. At one point, it was, developing infrastructure, setting up servers, for example, involved bringing a physical server on site, configuring it, setting up all its policies and security and so on. And it was literally a physical operation. And I can remember servers arriving on trucks and being installed.
Yeah.
And now servers are virtual objects which exist in the cloud, and you may have thousands of them. And in order to manage servers in the cloud, you can't do that physically and get in and configure everything on each machine individually. And so what you do is you save the configurations as code, which can then be modified and scripted and run at enormous scale. And it turns out that with analytics, we now can do something similar. Rather than the individual specialist crafting the perfect dashboard on their desktop and then deploying it, we now have, of course, many more objects and many more people engaged with the creativity of analytics, and therefore it needs a different approach. And the time has come when we have to learn from strategies like infrastructure as code and bring that into the analytics world. So this is very much something which the time has come, and we're ready for this.
I think it does beg the question, though, who is it for, right? So you mentioned and I think the comparison to the Middle Ages is very apt, right? Wherein we're kind of emerging from an era of analytics where it was this specialist who really understood the intricacies of the tool, and you would all have to go to that specialist in order to get your dashboards made. So how does that change with analytics as code? Like, it doesn't mean everybody should learn to code. Are we talking about business people writing Python, or is it something different? What is it really?
I really hope it doesn't involve business people writing Python. No, no. I mean, the as code. I think I said at the beginning, it's not misleading. I mean, the code is behind this, but it's not that you are writing code. It is that code is the way in which the objects that you're creating are saved, are realized, are made into objects that can be reused. That's what the analytics as code piece is about. You can still create those objects through user interfaces, through user experiences, which are visual and interactive. Of course, you can write code if you want to, and some people will, and some people use code to tweak objects that other people have created, and they'll copy the code and then use an interface to modify it. So no, people do not learn, don't need to learn to be developers. It's not like everybody becomes coders, but it's a paradigm for the infrastructure, the architecture of this process that makes it reusable, and that's why the term is appropriate, and it shouldn't scare people off, because it's really a way of enabling people to use a greater variety of approaches in developing business intelligence and analytics, and ultimately predictive analytics and even AI artifacts, rather than a restrictive approach.
Let me ask you too, you mentioned all the different types of analytics, and that last one, AI, obviously has been a very hot topic now for a couple of years with the advent of Gen AI and Gen AI coming into the analytics world, both kind of on its own and through vendor features that we're seeing added to different pieces of software. But how do those two trends do you see interact? Like the as code, and does that have a bearing on the Gen AI piece? Do those two work together? How do you see that forming as time goes on?
It's actually going to be super interesting, and we're at an early stage of that particular development. So this will develop over time. But one of the interesting things about code is that code is language. Code is it's a very specialized language, and it's a somewhat artificial language, but it's a language. And of course, the most exciting models that we see in AI these days are language models. And it turns out that AI is very good at generating code. Because it's very good at manipulating language. So you're definitely going to see the development of analytics models which are based on language, therefore based on code, that can be generated by AI, which means that rather than going to a development environment, an IDE, a visual environment, or rather than learning to code, you'll be able to ask a language model, ask a chatbot to help you build artifacts, and the chatbot will generate the code that is underlying that, and that is language, and it'll be extremely effective. Now, I see we're at an early stage of that. There's development that needs to be done, and we all know about some of the interesting things that happen with AI, but that is absolutely the direction in which things are going, and we should be pretty excited about that.
Yeah, that's very interesting. I see that too. Just, once you have this code-based analytics system in place, that it's just much more easy and obvious how the AI will interact with it, because that's exactly how it'll do it. The AI will be able to generate the code because it's language. You mentioned earlier this idea, the paradox of self-service, and I'm curious if you're someone who is trapped. Let's say you work at a company, you are one of these power user gurus. First of all, could you, because I think it's just so fascinating, and it's something I've seen over the course of my career as well, is just, there's the promise of self-service, but it's so hard to realize. Do you think analytics as code will get us closer to that? And if you are that person who is the expert in the BI tool, how do you see that transition happening, like to a more code-based world? What skills do they need?
Well, I think the transition that we're going to see is, of course, this transition from the individual being the individual center of excellence to a more collaborative center of excellence. And so one of the skills that they're going to need is a collaborative skill. Building something for reuse is rather different from building something that is going to be, single purpose. And a good example of this is when let me give you a very specific example of creating, say, a geography dimension, that describes the geography of a business, the countries, the regions, the cities, the states, the offices that a company works in. And every time we build analytics. We have a time dimension, we have a geography dimension. Geography is just one of these things that we have to do. And today we have to build it every single time. And the problem with that is that people have different views of geography. So finance thinks of geography in terms of tax jurisdictions, and marketing thinks of geography in terms of demographics and markets that it wants to reach. So those are different things, but they all ultimately have to align in some way. And if we can take a master dimension and inherit from it, then that becomes really efficient and valuable, but it also enables greater trust, greater reusability within the organization. Now, today, the process of doing that requires the highly specialized user to build something every time. And in the future, they will still be probably building some of those master dimensions, but they'll have to have a view to how is this going to be reused, and who is going to be reusing it, and what are the requirements of people downstream. So they're going to have to develop a somewhat different mindset. Maybe that's a better way of putting it. They have to develop a different mindset rather than a different skill set. They have to think about this as a collaborative process rather than a question of a sort of individual pursuit of a silo. We often talk in the industry about data silos, and we've put a lot of work into removing data silos where we can so that data can be shared. But actually, a lot of silos are silos of expertise and silos of people, which don't traverse our boundaries. People don't work across boundaries, and skills become siloed within particular organizations. And that's really what we need to change. So I think it's more of a change in mindset than a change of skill set.
That's fascinating. Yeah, that's really, I think it's funny. We talk so much as an industry about technology. And I think it's because the hype cycles in the industry are driven by technology vendors in many ways. So it's natural that we would do that. But with AI and now with analytics as code, I'm increasingly seeing the technology is important, but it's that change in mindset that we're going to have to embrace as data practitioners going forward that will offer maybe in some respects our biggest challenge, but also offers the biggest rewards on the other side.
Well, for sure. Changing mindsets is actually more difficult than changing skill sets.
Yeah, great. Well, I think that just about wraps up what we have time for today. Donald, if people want to follow you and catch up with your research and everything, where can they do that?
Well, you can find me on LinkedIn, of course. That's where I share a lot of my thoughts, and I'm regularly posting on a blog, but I post that on LinkedIn as well. So the easiest way to find me is through LinkedIn. I am on Twitter, X, whatever we call it now.
Yeah.
You can see me on there, Donald Treehive. I am called there, but I think LinkedIn is probably the safest place to find me.
Yeah, I can heartily recommend your Substack. It's fascinating. Every time it comes out in my inbox, I'm always happy to read it. The other place you can check out Donald's research, of course, is in our Analytics as Code white paper, which you can download at GoodData.com. So go check that out. It dives deep into a lot of the topics that we covered today: the paradox of self-service, the advantages of code, the reusability of code. So do check it out. And I want to thank you one more time for joining us here on the webinar today, Donald. It's always such a pleasure to talk to you.
Thank you very much. It's been great fun.
Okay, bye.
Okay, thank you guys. That was a very interesting interview, Ryan and Donald, and thank you both so much for your time today. Next up, we have our CEO, Roman Stanek, showing how good data is approaching analytics as code. Over to you, Roman.
Hi everyone, Roman Stanek, founder and CEO of GoodData. I would like to talk to you about analytics as code today and why analytics as code. I really enjoyed Ryan's and Donald's presentation or dialogue about analytics as code. And I would like to look into some of the key principles of analytics as code. So while we are kind of moving into analytics as code era, it's driven by the complexity of data and analytics. We are moving away from the simple dashboarding era into much more complex confluence of analytics, BI, machine learning, AI, Gen AI. And this complexity will require different practices and different engineering discipline to provide our end users with a consistent end user experience. And the best way how to do it today is to learn from software development principles. So what are these principles? There are fundamentally two. One is that all elements, and it sounds very complicated, all analytics, components like ETL, transformation, data models, metrics, different types of dashboards, user management, everything that actually defines the end user analytics experience can and needs to be described and manipulated and controlled through code. It doesn't mean that I, as an end user, need to define my dashboard with code, but I need to be able to take that dashboard, save it as code, put it into some code repository, version it, automate it, test it, collaborate on it, and so on. So this is the first step. We need to be able to manipulate through code. The second principle is that this code cannot be some sort of a machine only representation, as that's the way it is done today. It needs to be something that can be actually human readable, like Python, YAML, JSON, and so on. So I can actually go into that code and I can change my definition. I can define my metrics if I prefer working with code. So this kind of duality of visual and the code is the fundamental principle of analytics as code. End users work with visual tools, and engineers and operations people and testing teams can then work with code and fully automate it. And when we say analytics as code, we don't mean just visualization and dashboarding. We mean, as you can see on this slide, we actually we mean the whole end-to-end analytics value chain, if you will. Analytics as code starts with getting the data, transforming the data, managing the data, all the way through the semantic model, metrics, visualization, and dashboards. And it all can be actually put into an end-to-end solution stored in some GitHub or Bitbucket or any type of similar analytics and version control tool. So those are the two main principles of analytics as code. But let's take a look at GoodData and how do we actually plug it into the GoodData. So there are two components of GoodData solution, and these two components together, as you see on the slide, are producing the resulting experience. We can call it a data product. We can call it a dashboard. It can be any sort of experience that provides some analytics. And so what are the two components? One is the analytics as code data pipeline. I just spoke about it. It's the ability to download and transform and manage and cleanse and shape and just work with data. And then the second piece is the GoodData Analytics Platform that actually consists of multiple compute modules, BI front-end, AI experiences, multi-tenancy, different types of caching, semantic modeling, and so on. And these modules are all provisioned, managed, and defined as code. So if I'm an operations manager, if I'm an analytics manager, I can actually combine these modules into the data product, and I can actually combine it with my analytics as code data pipeline and manage it as kind of, again, end-to-end value chain. And the benefit of GoodData compute modules is that they can be actually deployed in any public or private cloud as long as this cloud supports Kubernetes. So we would call it Switzerland of analytics. We really work on any system in any location in any territory. And so this ability to manage good data compute modules and analytics pipeline, even remotely when it's deployed in multiple locations. That's one of the big benefits of analytics as code. And so let's kind of look at these benefits in totality. What are different ways how to look at analytics as code? So I just spoke about the ability to manage and remotely deploy and change. But the main benefit of analytics as code is actually increased productivity. I don't need to go and recreate my dashboard if I can just take a piece of code and copy it and duplicate it and change few lines. I can fully automate very complex analytics deployments with thousands of dashboards, with thousands of different data sources, all connected differently, because the code can be arbitrarily complex. And if you look at, again, I mentioned on the first slide that this is all inspired by the software, the best practices in software engineering. And our software engineers are deploying millions of lines of code that work in, very complex applications. So in a way, the data problem is actually relatively simple compared to the software problem. And yet, for many, many decades, the data and analytics was designed to be super manual, super brittle, and this is what we are changing. The next benefit of analytics as code is the ability to do rollbacks and versioning. So I can just test, I can experiment, I can build a new dashboard, see how it works. I can roll it back, I can version it. I can use different versions for different departments. I can use different versions of dashboard for different customers. It's all managed and deployed centrally. The next one is collaboration. And I think this is the fundamental problem with analytics and Donald Farmer spoke about it in his interview with Ryan. The fact that analytics always rely on a super persona, on some sort of analytics unicorn who knew how to manage data, who knew how to deploy some visualization tool, who knew how to actually get analytics done. And that obviously doesn't scale. We need to be able to scale analytics across the whole company. And that means involving multiple personas, data engineers, analytics engineers, testing teams, operations teams, quality teams, and so on. So the collaboration that the analytics as code enables with best practices and tooling and kind of CI/CD, continuous integration, continuous delivery processes is highly differentiated. And the last benefit of analytics as code is the ability to work iteratively. I can actually develop the first version of my dashboard. I can test it with my audiences. I can improve it. I can go back. I can share it with additional audiences. So ability to actually grow and kind of start small and expand with code is something that's unique to analytics as code. Because if I did it in Visual Tool, I would never be able to go back and see what changes I made and what would actually break if I make this change or that change. So the iterativity and productivity are the main benefits of analytics as code. So let's take a look at two examples. I have two videos here that I would like to share with you today that actually these videos demonstrate the benefits of analytics as code. So let's assume that I have my analytics project and I would like to deploy this analytics project to multiple, many departments or even clients at a large scale. So I will start with my production environment. That's the one I need to scale. And in a traditional way, I would have to go and just copy visually and make sure that I'm not making any mistake and And then, all the changes I would make to the original workspace, I would have to copy to new workspaces. With analytics as code, I can go into the code. I can start a routine that will create automatically multiple workspaces. And not only that, I have immediately workspaces or analytics spaces for my departments or customers. Because of the good data inheritance, any change I make to the original workspace will actually propagate to these workspaces. So now if I have an e-commerce company, I now have seven customers, or six original workspace plus six new ones, and they are all linked through inheritance. I can make changes to only one. So that's one example of analytics as code. As you can see, I can go to the newly created dashboard for customer A, and I see what was in the original template. So let's take a look at another example, and that is ability to update metrics, visualizations, and other objects across multiple environments. So let's say company is calculating DSO, days sales outstanding, and this DSO is either defined once or defined multiple times in accounting, in sales, in commission planning, any place where I need to know how my customers are actually paying. And this can actually scale. If I need to change this DSO, I can go to a piece of code. I can define this DSO once. And if I go to my code, I can see in this case, I actually have a customer account, and I can change my definition of my customer. I can redeploy the system. And from this moment, in every single dashboard, in any single visualization, in any metric definition, if I go and look at my customers, I can actually see that my customer is no longer 5,000, but 4,600. So you can actually see how quickly I was able to change my metrics and automate the full process. So that's the power of analytics as code. And thank you very much today. Thank you.
Thank you, Roman. And last but not least, our third segment of the webinar, let's hear from Vojta Kopal about how Mews is employing analytics as code to automate their pipelines and deliver analytics at extreme scale.
All right, hey everyone. Well, let's talk about analytics as a code at Mews and how we are achieving that with good data. I'm Vojta Kopal, Director of Engineering for Data, and for past 7 years I've been leading data engineer, data science, and data analytics at Mews. And our mission at Mews is to develop transformational solutions for brands and remarkable experiences for guests. And we do that by providing a hospitality cloud to our customers, starting from running an operation for individual properties, being able to really control the front office and back office staff with smart automation. We moved up to allow for multi-property management, so brands of hotels can use Mews to really control how each individual hotel is set up. It wouldn't be possible without open connectivity, open API marketplace, where we make sure that our customers can easily integrate their solutions with other softwares and tools. The goal for our customers is to monetize every square meter of their property, and that's possible with Mews Spaces. And as we are focusing on automation, it wouldn't be possible without great payments processing experience. All of this is really powering the guest journey. We're aiming for a connected guest experience that's memorable as well as modern. Looking at where we are with Mews today, since we were founded in 2012, we have more than 5,000 properties running on Mews. And we have more than 1,000 employees around the world. We were recently, we even gained unicorn status earlier this year in March. So how is Mews using good data? All of that product, all of that service and partnering with our customers wouldn't be possible without providing reporting and actionable insight. That's the key value that our customers are getting. And good data is helping us with that by embedding good data BI platform into Mews. We really aim for great user experience and consistency, and that's possible by applying our own design system to everything that we are building with good data. Ultimately, everything there is as a core feature for customers, but we can also benefit on offering additional add-on functionality that our customers can pay for. Let's have a look behind the GoodData platform at the data pipelines. At the beginning, we have partnered also with GoodData to help us to build this ETL process to bring data closer to our customers. We have a few challenges like automated provisioning, where we wanted to make sure that everything that is in GoodData can be provisioned from our system, from our product, whether it's users, workspaces, or user access control. We also wanted to be able to enable ETL for each tenant individually as per the requirements for our customers. To this day, we are able to run 48 pipelines loads in parallel to ensure data consistency for each of our customers. And it comes to historical full reloads. When someone starts using our BI solution, they might be with us for a while, and we want to make sure that we can fully load all their data into this BI. Today, we can historically full reload both any tenant, but also any endpoint, and we can choose the time frame for which we want to load the history for. Another challenge is the time zones. And as we want to be able to provide a also unified view as per some standard UTC time zone, each hotel operates in different region, different time zone. So we want them to be able to also use their local settings when they are looking at their data. And our customers are also used to bring the data outside of systems for their own analysis, for example, in Excel. And for that, we have built in a scheduled export functionality. So when I think about what's the value of as a code approach, I'm thinking this is default for me, as I'm coming from software engineering background where everything was as a code from beginning. And I'm so happy to see that this is now being applied across data engineering and analytics as well, because it brings so many great value for those who are building and using those solutions, like consistency and reproducibility, where we are able to use the same solution and deploy it across different environments like development, testing, and production. We are also able to easily apply the same solution for our customers, which is so important in such a setup like multi-tenancy that we have at Mews. We are able also to control the versions and be able to track back all the changes and understand when and what has been deployed. For the deployment, the automation and efficiency is key. Having everything tested and having those CI/CD pipelines in place, we can really rely on getting the latest codes to production in a safe and reliable manner. It also embraces collaboration, and we've seen both within Mews, between our product teams, but also when we are working closely with GoodData team. So could it be done manually? I don't think so. At this scale, we would very much struggle to support all the requests and onboarding and development without as code approach. The only way how this could work is like having a set of teams to be able to support all the needs that our customers have. So I think the S code is really the answer here. What's next for us? We want to double down on customizability. We want to allow our customers to be able to define, customize their view of their data directly in our product. That means being able to design their own dashboards, metric definitions, and bring in their own data as well. I can't forget about AI and LLM, and we are also exploring how can we benefit of using these techniques with GoodData for predictive analytics and next level of self-service. What are the results that we are seeing these days? Right now, it's about having empowered product teams. They are able to deliver consistent reporting. And for us, this is really a step away from when we were developing our previous BI solution with a centralized team. And that was happening in silo and disconnected from our product engineering delivery. Our teams are able to experiment faster. We've seen high-fidelity prototypes being developed by our product teams or product designers directly within GoodData UI and tested with our customers. All of this comes down to reducing time to value. So from initial idea, getting all the way to delivering value to our customers, this is now much easier thanks to GoodData. So this is what analytics as a code means for Mews and how we are benefiting from using GoodData. Thank you.
Thank you, Vojta, for tuning in and sharing your story. It's much appreciated. And thank you everyone in the audience for also tuning in today. I hope you found this session valuable. And now maybe your interest is piqued about how you could be doing analytics as code, or even just taking the first step in that direction of using it at your organization. The white paper that Ryan mentioned at the very beginning, authored by Donald Farmer, is a great place to start. We're going to include a link to that in our follow-up email. If you want to know more, we have some other resources for you. First, sign up for a free 30-day trial of GoodData by scanning the QR code here. Follow us on social media to learn about product updates. And lastly, we want to meet you. We have some upcoming opportunities for that. So we're going to be at Big Data and AI Paris in October. It's a free conference. So if you can get to Paris, it's free to attend and it should be a good one. And then we also have another webinar coming up on October 23rd about product features that were delivered in Q3 and also what's on the roadmap for the rest of the year coming up in October. So please tune in to that as well. Thank you for attending and have a great rest of your day.